Good morning, everybody, and welcome to another day here at Home with APS. I'm Miss Jacobson. I heard today that one of our students out there who's been watching calls me the Star Wars lady, and that made me feel really, really good. So if you are the student who said that, I want to say hi and give you a little shout out. I do love the characters in Star Wars. And so if you've been making puppets, like we talked about out of our Star Wars characters, by all means take pictures and send them to us and we will give you a shout out on the air. Boys and girls and grown-ups, we want to let you know too that starting in week number 5, we are going to be adding a new topic to our weekly schedule on Fridays. We're going to be adding PE. And so we will have 2 PE sessions every Friday starting on week number 5. We will have an 8 o'clock PE hour for kinder, first, and second grade. And then we will have an intermediate PE hour at 11 o'clock for grades 3, 4, and 5. And we have PE teachers from around APS who will be coming in and doing some activities with you that you can do inside and outside at your home. So we will make sure that we put that on our written schedule. And if you need to see that schedule, if you go to the aps.edu website and look under the More Resources page, it will take you to a page that has all of the KNME broadcasts, the links to the APS YouTube channel so that you can see those broadcasts again if you need to or want to. And it will have a schedule of what's coming up on the shows and all of the resources that go with them. So all of that is there, and we will continue to add to it as the weeks go by. So we've got a big day of plans, so we ought to get started. But I hope that you are ready, that you have your thinking caps on. And so let's get ready, set, go for another morning at Home with APS.
Hi, I'm Mrs. B. Welcome kinder and first grade. Today we're going to talk about science. Before we start with the lesson for today, last week we talked about light, and I was able to find a laser, and I wanted to show you a better example of reflection when light bounces back from an object. So I want to start us off just with that, a quick demonstration of that. So here's my laser pointer, and I'm going to point it at myself, not in my eyes. So if you have a laser pointer at home, be careful. Don't point it in anyone's eyes or a pet's eyes. But you can see the red dot. Do you see this red dot? Okay. I have a mirror here, and I'm going to point my laser at the mirror to show you how it bounces back onto me. Okay? Let's see if we can get this. Do you see that? See if I can get it on me. Where is it? Do you see it on me there? So I'm pointing the laser at the mirror, and then the laser light is bouncing back onto me. So I just wanted to show you, since I found a laser and I was really excited, and I wanted to make sure I had a good example to show you. So for today's lesson, we are going to focus on pushes and pulls and learn more about what that really means in science. So let's start by thinking of a time when you've had to push or pull something. We do that all the time, and sometimes we do it without even thinking about it. For example, did you have to push a door open this morning? Or did you need to pull a door? Or maybe you needed to pull on a light switch to turn on the light, or maybe you've held a door open. So you pushed open a door for someone to let them in, or maybe if you know someone in a wheelchair, you've pushed them in a wheelchair, or if you're in a wheelchair, you needed to push on the wheels to move forward. So think about all the things throughout your day that you do all the time to push and pull. So I brought with us some things for us to explore. And so as you're doing some pushes and pulls throughout the day, maybe you do push-ups or pull-ups on bars. I also want us to think about some things we can explore with the toys we have or things in our kitchen or around wherever we are. So I'm going to start with this string, and I put a little happy face on it, and it's taped onto a paper clip. You could tape it onto maybe a keychain or any other piece of metal. And I took a refrigerator magnet. So this magnet was on my refrigerator, and I pulled it off. Pulled. And so I want to show that here's another example. So my magnet is pulling my happy face onto it. Another example is a rubber band. So maybe you have some rubber bands at home, and we pull them apart. I also have some toys. So this toy is a little car that snaps into place here. And instead of pushing this car, I have to push this button, which is going to release this. So let's see how far and how fast this goes. Let me put it right here on the edge. Hopefully it doesn't fly off the table. Ready? I'm going to push on this button. So that's another example. Or I have this car that I need to pull back on, and when I let go, it goes on its own. Maybe you have scissors that you use if you're doing crafts at home or you see somebody using them. I have these tongs to pick things up. Found it in my kitchen, pick up some food. And so what are we doing here as we open and close it? Pushing and pulling, right? So think of different examples that you do throughout the day, pushing and pulling, and then think of all the objects that you're using to push and pull. And let's do a quick reminder of our 5 senses, because we always want to make sure we're using them when we're exploring around us. So quick look at our 5 senses. We have our sense of taste, which I'm not going to use too much today. Our sense of smell, again, not going to use that one that much today. Our sense of hearing, I might use that because I noticed when I did the push button, I could hear there's maybe a little spring in there. So we might use that. Our sense of touch, we use that all the time. And so think about the different objects that I showed you. Think about the things you have at home. How would you describe them? How do they feel? I'm going to mostly use my sense of sight today to pay attention to objects as they're moving. And so for all of these things, let's ask a couple of questions. Remember, it's always important to ask questions. So with the different objects I showed you, or as you were thinking about your days and when you push and pull something, what are some questions that come to your mind about pushes and pulls? So let's start with a what if question. What question would you have about a push and a pull? I think about, what if these tongs were really hard to pull apart? Would I need to have a harder push or pull? How about a when question? When do we know to push? When do we know to pull? Something to think about today. Why? Why did this car move slower than this car? What's a why question you have? How about a what question? So my question is, what do we call a push and a pull in science? Because there is a scientific word for it, and we'll get to it. How about a how question? How can I make this car go faster? Because it went sort of slow, in my opinion, the first time. How can I make this go faster? So I hope you're asking all sorts of questions as we're exploring today. So a push and a pull is called a force in science. Spell it with me. Ready? F-O-R-C-E, force. So when we're pushing or pulling on something, we can say, let me use some force to open this door instead of let me push open this door. But we can start using this word now when we think of pushes and pulls. And so some things we want to think about when we push or pull is the direction that something would go. So what are some of our directions? And let's see if we can make some predictions. Remember, when we predict, we are saying what will happen before it happens. So, do you predict that I could make this car go in a different direction? So I made it go in this direction. Could I make it go in a different direction? So let's review some directions that we can describe our force, right, or our objects. What direction are our objects moving? So when we use a push or a pull, we can make an object go up. We can make an object go down. We can make an object go backwards. And we can make an object go forwards. And we're going to explore this a little bit more. We also need to think about the strength of our push or pull, and that's how we're pushing or pulling. So we can describe the strength of a push or a pull as hard or soft. A hard push. So think about maybe if you've ever pushed someone on a swing, you pushed something on a string, or you've pushed yourself on a swing, or you've pushed someone else in a rolling chair, in a wheelchair, a hard push. What would that feel like? What does that look like? Compare that now to a soft push. What would that look like? What would that feel like? So we can use different strengths, how hard or how soft we're pushing or pulling on an object. Or maybe we can feel that. If we were the one in the swing and somebody pushed us really hard, what would that feel like? We can also talk about pushes and pulls as speed, how fast the object is moving because of a push or a pull. And we can use words like fast and slow to describe the speed. And then we want to think about maybe all these things together. So what kind of a push do you predict we would need the strength to get an object to move fast? So if I want this car to move fast, what kind of a push would I need to give it? A soft push or a hard push? And there went my car. So think about those things. And then what direction did my car go? Well, I saw that it went straight and then it took a turn and it dove right off the table. So let's practice more with our direction, our strength, and our speed. So here are some directions we're going to practice today. So U is for up. And we want to practice drawing our arrows. So an arrow is a straight line, and you can start from the top down, or you can start from the bottom up. And then wherever we're putting our slant lines, two slant lines that meet at the end of the line, like this, we want to make sure that's the direction we're describing. So notice that my two lines come together so that it's showing me up versus down. D is for down. And so if we want to draw an arrow pointing down, we can start a line from the top down or from the bottom up. Either way, we want a straight line. And then we want to show with our two slanted lines at the end here that we're pointing down. So the slash marks, the slash lines I should say, tell us what direction we want to go. And then we want to talk about forward. F is for forward. And so I'm calling this forward, and I'm calling behind me, away from me, B backwards. So backwards that way, forwards this way. And if I was facing this direction, I would call forwards towards you, and I would call backwards away from me, behind me, still this way. And if I was facing this direction, this would be forward away from me, backward behind me. So those arrows might change, but for the board, I drew forward in this direction and backwards in that direction. So stand up, and I want to give you some clues for a push and a pull, for a force, and then I want you to tell me and I want you to show me what it would be. So what am I saying here? We're going to look at up, down, forward, backwards, and we're going to look at fast and slow and hard and soft. So show me a hard push. What would that look like? And it's not push anybody or anything around us, okay? Just in the air. So what's a hard push? What would that look like? That would be my hard push. But I'm not pushing anybody or anything, just push in the air. What would be a soft pull? Show me that. A soft pull. Gently, slowly. What would happen if we did a hard push to a giant ball? How fast would that ball move? Would it move fast? Would it move slow? I predict, what do you predict? That it would move fast if I gave it a hard push. So what about a soft pull down? Show me that. What would a soft pull down look like? I have a piece of rope, I'm pretending I have a piece of rope, and I'm pulling it down softly. So my object, let's say this rope was connected to something else. We'll use this as my example. I don't know if you can see my string here. It's very thin. So I'm going to do a soft pull, and my object moves really slowly. What about a hard pull down? I'm going to pull on my string hard and down. My object went really fast and then it flew off. What about a pull forward? What would that look like if you're pulling something forward? I'm going to pretend I have a wagon behind me and I'm pulling forward. What about backward? Something backward. Can you think of something backward? What if we're pulling the wagon backwards? So I'm holding the wagon from this side and I'm pulling the wagon backwards. So think about all of these different things. Think about when you push or pull on something, the force that you're using. What direction is whatever you're pushing and pulling going to go? How hard or soft are you pushing or pulling on that? How fast or slow will something move because of your strength, how hard or soft you pushed on something? And so I want you to think about drawing some pictures to show what you learned today. Think of an object, a car, a bicycle, some tongs, scissors, whatever you used, and use arrows in your drawings to show direction. Show whether something's going up, down, forwards, and backwards. And then show maybe how your object is moving. How can we draw something moving fast or slow? How can we show a hard push or pull with our drawings? Think about that. So practice your directions and think about pushes and pulls today throughout your day. So until next time, I hope you have a great day.
Good morning, learners. I'm Miss Abby, and today is a special day. I was looking at my calendar this morning. I keep a calendar on my refrigerator, so I remember important days or even what day of the week it is. And I saw today is the last day in April. Today is April 30th. What that means is it's time to build my next calendar. So as I'm looking through all the fun things that happened in April, I get to start planning what will happen in May, my next month. If you go on our aps.edu website, you can download and print one of these blank calendars. These are helpful. They are not specific to any month because you can add each new month at the top of the paper. Since this is a little small, I'm going to build a calendar here. If you want to build a calendar with me, will you go grab a blank sheet of paper? Maybe you already have paper out. Have you noticed we do a lot of writing and drawing in this? We do. So what I'm going to start with is a rectangular shape where it's longer on the sides. I'm going to start at the bottom. I drew some lines. I'm going to draw 1, 2, 3, 4, 5, 6 lines, but they're not all even. It's a little tricky. I'll start with my first. Ooh, I tried to be straight. 1, 2, 3, 4. Whoa, that one is very wobbly. 5. I'm going to draw a thinner rectangular box. And I'm going to leave a little bit of space at the top here to write my date. I'm going to write my month and my year. Now, before I start writing, I want to build my vertical lines. Vertical goes up and down. So, 1, 2, 3, 4, 5, 6. You know what? This is bothering me a little bit. I'm going to straighten that one out. I like working with whiteboards. They're easy to erase. Now, since I have 7 days, I want to make sure that I'm drawing enough vertical lines so that I can have a Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And maybe I just erase these horizontal side to side lines. And this can be reminders. All right. Look at how many boxes I have in my blank calendar. 1, 2, 3, 4, 5, 6, 7. Do you know what 7 plus 7 is? It's a doubles. 7, 14. Let's keep counting. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. This is a lot of boxes. 36, 37, 38, 39, 40, 41, 42. I have 42 rectangles here in my blank calendar. The calendars that I said you could find online also have 42 rectangles inside of them. Now, we are making a calendar for the month of May. May, capital M-A-Y. That's our month. And our year is 2020. 2020. 2020. May is the month, and the month changes about every 30 days. The year changes about every 365 days. But every month, you will see the same days. The first day in the week is Sunday. S-U-N, day, D-A-Y. Sunday, I started with a capital S. After Sunday, Monday, capital M-O-N-D-A-Y. It also has day. Sunday, Monday, Tuesday. T-U-E-S. Tuesday. D-A-Y. Wednesday. This is a long word, and there are some tricky letters in Wednesday, but I know what it begins with. Wednesday. W-E-D. Wed. Nez. N-E-S. Wed. Nez. Day. D-A-Y. Wednesday. Sunday, Monday, Tuesday, Wednesday. Thursday comes next. Capital T-H-U-R-S. Thursday. What three letters come next? D-A-Y. Thursday. One of my favorite days of the week is Friday. What does that begin with? Friday, capital F-R-I. Day, D-A-Y. Friday. And the last day that we will write is Saturday. Saturday. Capital S-A-T-U-R-D-A-Y. Saturday. Every month has Sundays, Mondays, Tuesdays, Wednesdays, Thursdays, Fridays, and Saturdays. On our blank calendar, I already wrote the days of the week because those are the same in every month. Now we're in May. Next month is in June. When I look at my April calendar, today is Thursday. Tomorrow will be May 1st. Tomorrow starts on a Friday. This is tricky to know. Where do you put the first day of the month? Well, you have to look at the month before to see where it ends. April has 30 days. So April 30th is on a Thursday. May 1st is on a Friday. Let me find the first Friday in May. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. This is the first Friday, so I will put a number 1. There are 31 days in May, so I'm going to start writing my numbers 1 through 31. I wonder what day May will end on. Why don't you do a quick prediction? What day of the week do you think May will end on? Let's find out. Friday, May 1st. Saturday is May 2nd. Sunday is May 3rd, so I will put a 3. Monday is May 4th. Tuesday is May 5th. Wednesday is May 6th. Thursday, May 7th. 1, 2, 3, 4, 5, 6, 7. On Friday will be May 8th. This is our second Friday of the month. After 8 comes the number 9. After 9 comes 10. Now we're into 2 digits. This date has a 1 and a 0. Ooh, we're into double digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Next comes 11, 12, 13, and I'm going to keep writing my dates until I get to the number 31, because there are 31 days in May. 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. I'm out of rectangles, but I have one more day to add. Sometimes in calendars, you will see what I wanted to do was put 31 on Sunday, but I have no more Sundays. This is tricky. So what I'm going to do is I'm going to divide this Sunday, and I will write 31. There are 1, 2, 3, 4, 5 Sundays in May. 5 Sundays. How many Mondays are there in May? Let's look at all the Mondays with a number in the rectangle. This one does not have a number, so I'm not going to count this one. 1, 2, 3, 4. 4 Mondays in May. How many Tuesdays? 1, 2, 3, 4. 4 Tuesdays in May. 1, 2, 3, 4. 4 Wednesdays in May. How many Thursdays are there in May? 1, 2, 3, 4. All right, it's going to change a little. How many Fridays are there in May? 1, 2, 3, 4, 5. There are 5 Fridays in May. I count each of the rectangles that have a number in them. So how many Saturdays are there in May? If you said 5, pat yourself on the back. Good job. There are 5 Saturdays in May. Wonderful. Now, when you make your calendar, you can just put the new dates and leave it like that. When you know about appointments or birthdays or special days, you can write them on the calendar. Did you know I have an Aunt Ruthie? You probably didn't know that. Her birthday is on May 4th. So I'm going to write, it's Aunt Ruthie's birthday. That way I'll remember to give her a phone call. So I will say, Aunt Ruthie's birthday. On your calendar, you don't have to write Aunt Ruthie's birthday, because that's my Aunt Ruthie. You can ask someone in your house if they have a birthday in May, and then you can write it down. You can also write down your cat's birthday or your dog's birthday. If someone important in your life has a birthday in May, write it on your May calendar. That way you'll remember to make them feel special. Now that I have my calendar, I want to do some riddles. Now, I made some riddles that I have to use my May 2020 calendar to solve these riddles. I have 2 different riddle cards, and hopefully we can start making more riddles together. The first riddle has 3 clues. 1, 2, 3. I don't want you to see my answer though. The first clue asks, I am an odd date. Odd. Odd. An odd date means that it does not have a partner number. So odd dates would be the first, 2 has a partner, 3rd, 5th, 7th. Oh, look, there's a pattern. It's every other one. 1, 3, 5, 7, 9. These are all odd numbers. And then it keeps going because 11 has a 1 in the ones place. There's another 3. 13 is odd. There's a 5. 15 is odd. 7. 17 is odd. 9. 19 is odd. I have more odd numbers in my calendar. 1. 21 is odd. 3. 23 is odd. There are so many patterns in math. 5. 25 is odd. 7. 27 is odd. 9. 29 is odd. And our last day in May, May 31st, is also an odd date. So do you know what my special date I have? No, there's too many options. My next clue says I have 2 digits. 2 digits. So these first odd numbers only have 1 digit. It can't be them. Wow, look at all these 2-digit odd dates. I'm going to need another clue. The next clue says, I am 1 week after May 6th, 2020. I am 1 week after May 6th, 2020. Let me find May 6th, May 6th. 2020, but it says I am 1 week after. A week is 7 days. I can also do a quick jump down 1 week. I think it's May 13th, 2020. I'm going to count 7 days just in case. 1, 2, 3, 4, 5, 6, 7. Yes, I double checked my math. And I think the secret date is May 13th, 2020. And that's right. The date is May 13th, 2020. I have one more riddle for you. What date am I? The first clue says I'm an even date. So all of those circles, it can't be any of those dates. The next clue says I have 1 digit. Oh, so it can only be an even number with 1 digit. I will double underline even numbers with 1 digit. Even number, 1 digit. Oh, that's a 2-digit number. The last clue, I love the last clues. They usually help me laser point. Says, I am on a weekend. Weekends are Sundays and Saturdays. I have 2. That's the only even single-digit date that's on a weekend. So that has to be my answer. The date is May 2nd, 2020. At home, you can make riddles too. You want to come up with an answer where only one answer is correct. My way is I think backwards. First, I wanted to use May 13th, so then I built clues to help me lead you to May 13th. We can talk more about riddles later. Thank you so much for learning about calendars with me. Tomorrow is May 1st, and I hope you have a great month of May. Before Miss Q comes on for our read aloud, let's do a quick stretch together. Have you been sitting a while? All right, everyone stand up with me. Go ahead and stretch. Feel your back look like almost a turtle shell. It's all round. We're going to count to 100. We're going to skip count to 100. Are you ready? Stand up. Take a deep breath. Let's count by tens. I want you to touch your elbow. And when your elbow hits your knee, you're going to say 10. Are you ready? Take a deep breath in. 10. Let's use our next elbow. We're going to say the next group of 10. 20. Next elbow. 30. Don't forget to let that air out. Take a deep breath. 40. 50. 60. 70. 80. 90. 100. Good job. Go ahead and shake out. Sometimes when I'm learning, I need a body break. All right. You can go ahead and get cozy because now we have a read aloud. Have a great day. Thank you for watching At Home with APS.
Good morning and welcome back. Hopefully that brain break let you get all your wiggles out so now you can hear my wonderful story. Today I'm reading 100 Hungry Ants. The author of this story is Eleanor Pickneys, and it's illustrated by Bonnie McCann. This story is also published by Scholastic Books. 100 Hungry Ants. Have you practiced counting to 100 lately? Well, you just did with Miss Abby. So you're ready to hear about 100 hungry ants. A whole hill of hungry ants, their faces all aglow, came swarming from the forest to cross the field below. A soft breeze fanned the sunshine and whisked them on their way. It hinted of yummies for their empty tummies. That means a picnic. Hooray! These ants are so tiny. I wonder if you can see them. But they start up here on their anthill, and they walk all the way across, and they're headed down. If you can see it, a little picnic is waiting for them. I wonder if they'll make it in time. 100 ants were singing and marching in a row. We're going to a picnic, a he and a hi-dee-ho. I see some other animals who also might see that there is a picnic waiting. Which animals do you see? I see a squirrel and a bird. I wonder who will make it there first. Stop, said the littlest ant. We're moving way too slow, for some food will be long gone unless we hurry up. So, with 2 lines of 50, we'd get there soon. I know. He's a pretty smart ant. All the ants raced here and there and up and down and to and fro. There'll be lots of yummies for our hungry tummies. A hey and a hi-dee-ho. You can see that they're rushing around. 100 ants were singing and marching in 2 rows. We're going to a picnic, a hey and a hi-dee-ho. I see the ants marching this direction toward the picnic, but I also see some animals moving this direction, maybe with some of the food. I hope they can get there in time. Stop, yelled the littlest ant. We're moving way too slow. More of the food will be gone unless we hurry up. So, with 4 lines of 25, we'd get there soon. I know. All the ants raced here and there, up, down, and to and fro. We hope there's yummies for our rumbling tummies. A hey and a hidey-ho. So the ants went from 2 lines into 4 lines, thinking that that was going to make them faster. What do you think? 100 ants were singing and marching in 4 rows. We're going to a picnic, a hey and a hidey-ho. Uh-oh, I see some more animals. And these animals have the picnic food. I see a skunk and 2 chipmunks and a tiny little mouse. But I also see the ants marching in 4 rows going down to that picnic. I hope there's still some food for them. Stop! Screamed the littlest ant. We're moving way too slow. Lots of food will long be gone unless we hurry up. So, with 5 lines of 20, we'd get there soon, I know. All of the ants raced here and there, up and down, to and fro. There might be a yummy for a grumbling tummy, a hey and a hidey-ho. So do you think if you move in shorter lines, will they get there faster? Does moving in a shorter line get you there faster? I'm not sure. But now they're in 5 lines of 20. Let's see what that looks like. Here they are, 5 lines. 100 ants were singing and marching in 5 rows. We're going to a picnic, a hey and hidey-ho. I see the ants, but do you see the other animals too? There's a mouse and a squirrel and a duck. And what's this over here? A raccoon is hiding with an apple also. I don't know if there's going to be any food left for the ants. Stop! Shrieked the littlest ant. We're moving way too slow. All the food will be long gone unless we hurry up. So, with a line of 10 and 10 lines of 10, we'd get there soon, I know. All the ants raced here and there, up and down, to and fro. There'll be yummies in our grumbling tummies, a hey and a hidey-ho. So every time the ants have to stop and reorganize and get into new lines, do you think that's making them faster? I think that's making them slower. Oh no. 100 ants were singing and marching in 10 rows. At last, we're at the picnic, a hey and a hidey-ho. But I see a turtle with some cake and a snail. Even the snail got there faster than the ants. But here are the ants in 10 rows of 10 marching up to the picnic. I wonder if they'll make it. Stop! Yipped the littlest ant. We've traveled way too slow. There's no food for us to eat. You took so long with the rows. Oh no. So this ant, whose idea it was to change into different rows, is now saying that's what made them too slow. And there's no more food. Oh no. All the ants raced here and there, up, down, to and fro. There aren't any yummies for our growling tummies, a hey and a hidey-ho. Oh no! And you can see all of the plates and bowls that are empty. These poor ants. 91 ants were swarming from each and every row in a hot pursuit of one little ant who quickly turned to go. It's not all my fault, you know. And he's running away. Do these ants look happy? They are not happy. They look very angry, and they're not marching in rows. They just ran. And here's the empty dish with no food for the 100 hungry ants. Oh, that just makes me so sad. Thinking of those poor ants, they could have gone one by one. Would that have made them faster or slower? When you count to 100 by ones, can you count fast or slow? With Abby taught us today to count by tens. And I think when we were counting by tens, it went pretty fast. So the ant had a really good idea when he was counting by tens that that would be the faster way. But maybe not when you're marching. Up here today, I have a 100s chart. I drew this on a piece of paper for you. You can draw one at home, or you can download one if you want to do some hundreds chart games with us today too. I started with number 1, and I went all the way down to number 100. So we were going to think today about how the ants went marching. First, they were marching one by one. So every ant was following in a long line of ants. Then they went marching by 25. So here's, oh, I'm wrong. They went marching in 2 rows of 50. So here is my 50. I'm going to circle it. 50 is right in the middle of 100. If we count 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So that's how they were able to march in 2 rows of 50. But then the ant thought that wasn't fast enough. So then they went into 4 rows of 25. Here's my 25. So we had 1 row of 25. The next row of 25 got us to 50. What's 50 and 25 more? 75. So we have 25, 50, 75, and how many ants were there? 100. So here's my 100 down here on the bottom. They went counting, marching in rows of 25. So there were 4 rows. And then they went in 5 rows of 20. Can you help me get to that? So I can count by ones, or I can just say 10 and 20. So here's my 20. What would be the next number? That's right, it would be 40. Counting by 20s is pretty easy. What would come after 40? That's right, 60. I'm just adding straight down my tens row, and I'm skipping 1, 60. Skip 1. What would be the next one? 80. And the last one, 100. So that's how they went marching in 5 rows of 20. Here's my 20, 40, 60, 80, and 100. Then they broke up into one more pattern before they got to the picnic. Do you remember how they were marching? They were marching in rows of 10, just like my 100s chart. So you had 10 ants marching, then 10 more ants marching, 10 more ants marching, all the way to get to 100. How many rows are there to get to 100? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 rows to get to 100. Let's count by tens, just like Miss Abby did. 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. If you're at home and you have a hundreds chart, what other patterns can you come up with to play games with on a hundreds chart?
Can you find all of the odd and even numbers like on your calendar? Or can you come up with some games to challenge your family at home? We hope you enjoyed learning with us today about push and pull, about using a calendar, and about practicing counting to 100. Thank you for joining us for another day of learning, and we hope you have a great day. Thank you for At Home with APS. We hope to see you back tomorrow.